Hey everybody, here we are back for day number 2 of remote learning. Welcome. On lesson number 1, you had a little bit about the beginning of chapter 4, and the big word being used was the word work. Work, we figured out it's when you exert a force on an object and you make it move. So not only does it have to move, but it also must be in the same direction in which the object ended up moving. And this is what our whole lesson was about, just the word work. I showed you a little bit of math that we did with work. Work is measured in joules. It is equal to a force times a distance. Forces are given a unit of newtons, which is named after Isaac Newton. So there was a little bit of math that we went through on here. And then we move on into our next section, which is section 2, which is talking about mechanical advantage and efficiency. This part will happen in 2 parts. Part 1 will be just like an intro to this, and then the second part is going to go into mechanical advantage a little bit more. Today's going to look at more what is a machine and what forces are being used while you're doing work. First of all, we're looking at a machine. There's 6 types of machines. They're called simple machines. Just a couple examples. These are not forms of simple machines. These are just machines in general. So a shovel, a ramp, and a dolly. A machine is something that's going to make work easier for you to complete. Rather than digging with your hands, you can use a shovel instead. Shovels allow for much easier. They multiply for force, and it also changes direction. Ramps are awesome. Rather than having to lift a heavy object up a big step, instead you can put wheels underneath the object, and then you can pull it up a ramp. It's going to be much easier for you, and you're going to exert far less energy while doing it. And maybe a dolly. Dollies are great for moving heavy furniture. They're little two-wheeled machines, and you put something on there like a fridge or a big filing cabinet, and you pull it back, and then you can push it around, similar to a wheelbarrow, how that works. But there's going to be 2 forces that are used when you use a machine. The first one is going to be called an input force, and that is what you are exerting on the machine. So you put force into the machine, and then the machine puts out a force in order to complete the task. That's the output force. In terms of labeling of these, input force is usually labeled F sub I, so like F and a tiny I. Output force is usually labeled F with a little O. Uh, that'd be those 2 types of forces. There's 3 things that a machine can do. So in order to make your job easier, it can change how much force you exert, usually multiplies it in order to make things easier for you to do. The example I always use is with a can opener, like an electric one. All you literally have to do is press a button. And the force that you put in by pressing a button is multiplied by the machine, and it spins that gear in order to open a can. It could also change the distance in which you exert an object, this or exert a force. This would be with an inclined plane or a ramp. Lifting up the heavy object is a very small distance, but it's going to be a lot of work because it's a very heavy object. So instead, you increase the distance at which you apply that force. You pull it up a ramp instead. Your job just got easier. Or you can change the direction in which you exert a force. An example here would be a pulley system. By pulling down on the rope, think of a flagpole. You pull down on the rope, the flag goes up. This would be a pulley system. Now, the direction is being changed. Same thing with a sail on a boat. You pull down on the rope, and the object goes up. So these are 3 things that machines can do for you to make your life easier. Some machines have greater output. They get multiplied. That was one where I talked about the can opener, but examples would be Other ones would be levers, wedges, and pulleys can do that as well. With a lever, an easy lever would be something that you flip. Think of a light switch. You apply just a tiny little force to a light switch in order to flip that. But there's a lot that goes on after you flip that. So just your little bit of force that you apply as an input force changes a lot of things. Wedges. Think of an axe. You have a wedge. It has a wide end that comes to a sharp end, like the tip of an axe. Very sharp, very small. When you go to chop wood, it breaks at where the small point is, and the force spreads out through the wood, breaking it. What else we got in here? Machines have other ones that have greater input force than output force. Now, statistically, this doesn't sound very appealing, where you have to put in a lot of force and then you only get a little bit out of it. That just doesn't seem too useful. But a great example here is that inclined plane. Yes, you're going to put in more force total, but the job is going to be much, much easier for moving that heavy object up an incline. Final example here, ones that do not multiply force or distance, they change direction. This is your pulley again. You pull down on the object goes up. Think of a flagpole, a yacht, or a boat that has a sail on it. You pull down on it and it flies upwards. And this is just a few things the machines do. Your next lesson is going to look at mechanical advantage, which is it's a ratio of the force being used to do the job. So if you have an output force of 3 and you had an input force of 1, your mechanical advantage here would be 3 because your force was multiplied by 3. The efficiency, if the output force was 3, but the projected output force should have been 4, you would have what's called a 75% efficiency. You produce 3/4 of what you should have, which is 75% efficient, which actually isn't too bad. I'll give more examples of efficiency and mechanical advantage in our next lesson. I'll see you soon on our Google Meet.